Math 3, Unit 2, Section E, which goes along with Worksheet 5. Today we're going to talk about solutions of functions. Okay, so when a solution of a function is usually where? Where a point crosses the x or y axis. Very good. Okay, so on this, if you notice, like, we have just points with an answer at that point. It doesn't give you ordered pairs, okay? And so when they say list all the labeled points that are solutions for f of x equals 0, remember that f of x equals 0 really is y equals 0, or you can think of it as your x-intercept. Okay, so you're finding the points where the y is 0. So it has to be on the x-axis, right? So you have a value for x, and then 0 on the y. So if you look here, which 2 points would be the answer? Good. A and E is correct. Okay, now it says list all the labeled points that are solutions for y equals f of x. Well, right here, this graph right here is y equals f of x, okay? And so any points that are on this function are solutions. So which points are on that graph? All of them, exactly. A, B, C, D, and E. Okay, so then the next one says, list all of the labeled points that are solutions for x equals 0. So when x is 0, that means you're actually finding the y-intercept. Okay, so if x is 0, so remember you'd have 0 and then you'd find the value on the y, right? So if x is 0, it's the values on the y. So what is the value? Which one has a x equals 0 point? D. Good. Okay, and then there's one more question that's not on here, but it's actually on your homework. And it asks you the answer of where f of 0. And so f of 0 is basically wanting you to find the answer when you plug in 0 for x. Well, that's kind of what we have right here, right? But what they're looking for, though, is the actual value at this point. So f of 0 would actually be the y value at point D. Okay, so looking at like what we've done here, we know f of x equals 0 is really saying y equals 0. So you're finding the points where y is 0, which is your points on your x-axis. Okay? Points that are a solution are points that are on the graph. List all the points that are solution for x equals 0. So when x is 0, that's when you're finding your y-intercept. Okay? And then if they ask something like this, f is 0, that's asking for the actual value at that point. Okay, so I want you guys to kind of work in your groups and try to get the answers on this one. So just attempt it. Look at what you learned on the last one and see if you can figure out those letters. And I'll be walking around checking, and then we'll go through it together. So talk about it. Read the questions. You know what? We didn't really talk about which graph was which, did we? This will change your answers. Oh my goodness. Okay, so this one we're going to say is g of x. And your parabola is going to be your f of x. So obviously that's important when you are deciding things. Yeah, I just disagree with C right now.
Oh, that makes more sense.
But I'll change that. Good. So A is right.
Dude, that's like me.
Oh, I thought you did.
Why is it not installed?
Choice he had. That's so sad. I teach the cello. I was a principal player. First chair.
What's that?
I can see.
Slightly allowed ranked by chairs. And on the first chair basis. So that was odd and typical for on first chair. Which means if I'm like the lead player.
Oh,
I'm the lead bass player.
okay, good.
Yeah.
Wow.
I hate myself.
They said, oh, you play the bass? I'm like, no, I am.
All right, so some of you are talking a whole bunch about not this assignment, and so therefore I think it's time to start. Okay, so when it says f of x equals 0, that means we're looking at our f of x graph, okay? And we're finding the points that it crosses the x-axis. So which I just gave you half a hint, but which letters are where it crosses the x-axis?
A and D.
It doesn't actually cross a G, right? It crosses at A and D. This isn't part of f of x. Do we agree with that? Okay, so A and D. Is there any confusion on A there? Okay, B. B says, list all the points that are solutions for g of x equals f of x. So whenever you have them equal to each other, you're finding their points of intersection. So where do the two graphs intersect? Which points?
B and E.
Very good. B and E. Okay? And so I'm going to actually just like highlight, oh no. Oh, it still works. Okay. My f of x graph, just to kind of make it look slightly different. And we can see the 2 points here that they both intersect is at B and E. All right. So the next one says, list all of the labeled points that are solutions for x equals 0 on f of x. So where does x equal 0 on your f of x graph? Only at C. So this is where you're at 0 for the x, and then you have a value on the y. So C is the only one that will work on this one.
G's just there, isn't it?
G is just there to confuse you. Exactly. Okay. Okay, do we have questions so far at this point? Okay. Then D, the question says, list all the labeled points that are solutions for y equals f of x. So what are the answers for y equals f of x? What are all the points on the graph?
A, B, C, D.
Good. A, B, C, D, and E. Okay, and then it says list all the labeled points that are solutions for y equals g of x. And those would be, good, D, F, H, and E. Because, oops, just kidding, B. Thank you. B, F, H, and E. Okay, so pretty confusing, pretty easy. Pretty easy?
Very, very hard.
Very difficult? Okay. All right.
More difficulty.
Wow.
Oh my god. It takes Spanish for me.
I passed Spanish.
Okay. So this is slightly confusing. Hopefully I will make it less confusing, but I think you guys will understand it. Okay, so Basically right here we have an f of x function, a g of x function, and an h of x function. So if you were to graph this, how many different graphs would you have? 3. Okay, so I'd like us to use 3 different colors. Okay, now you are able to graph these, but I find that when I'm actually going to end up finding these answers, it's easier to look here at the chart than it is to look at the graph. But maybe you'll be the opposite. I don't know. Okay. Okay, so I'm waiting for you guys to get out your colors here. Perfect. Yeah. I actually have some colored pencils if you want them. So here are some colored pencils if you want to use those. You're welcome to. Okay, so let's start with f of x. So notice that they have an x value and then they have the f of x value. The f of x value is actually your y. So this 0, negative 2 is an ordered pair. So if we go and plot that, we have 0 and then down 2. Okay, then it goes 1, 0. And then we have 2, negative 1. 3 is at negative 4. And then 4 is at negative 2. Now, we don't know exactly what's happening between each of the points because they didn't actually give us the function, like the equation. Does that make any sense what I'm saying? But we're going to go ahead and just kind of connect the dots. So it kind of gives us an idea of what this graph may look like. Okay, so now we're going to go to the g of x graph. Oh, and I would label right here that this is f of x, or do something like, you know, red is f of x. Okay, so g of x I'm going to do in green. So what would be my first ordered pair for g of x? Very good. So we're using the same x here, but it's going to go 0 and 4. So 0 and then up 1, 2, 3, 4. And then the next one we have at 1, 1. So right 1, up 1. This one is at 2, negative 2. Is anybody confused by any of this right now? So we're always using the x, and then this is our y. Okay, so the next one's at 3, negative 6. And then we have 4, 1. Okay, and again, we're just kind of connecting the dots to give us an idea of what the graph might look like. But we don't actually know that that would actually happen. Okay, and I'm going to label this one is g of x. All right, and then our last one, h of x. Let's go ahead and do that one in a different color. And like right now, do you see how like at one point g of x is bigger than f of x, and then at one point here f of x is bigger than g of x, and then it changes again where g of x is bigger than f of x. Do you guys kind of see how it's changing back and forth? Okay. H of x, we have 0 and negative 1. And then we have 1 up 3. And 2, 1. 3, negative 2. And 4 is at negative 1. Okay. So this first question is talking about only f of x and g of x. So it says on the number line below, shade the intervals between the integers where the solutions to f of x equals g of x must exist. Okay. If not, then you would explain why it's no solution. Okay, so right now I'm looking at f of x and g of x, and I would take your pencil. This is what I found to be the easiest, because your solution will be when they change. So a solution is where they cross, right? And so if you're looking here, we're looking at the red one and the green one. So there's going to be a solution, it looks like somewhere around maybe between 1 and 2, it looks like on here. Because see how the graphs end up crossing at that point there? So you're trying to find the point when they cross. Well, the point they cross is when one changes from being bigger to being smaller. Okay? So what I mean by that, when I look at this of f of x and g of x, right here f of x is smaller. So I'm just going to put an s here for this being smaller than g of x. Then at the next point, do you see how negative 2 is smaller than 4? Does that make sense? That's how I'm saying smaller. Okay, and then f of x here is still smaller than g of x because 0 is smaller than 1. So it's still smaller. But then when you get here, do you see how negative 1 is actually bigger than negative 2?
Yes.
So it changes. So I'm just going to put B for bigger. Then I look at the next point, negative 4 and negative 6. Here again, it's still bigger. And then when it goes here, negative 2 to 1, now here it is smaller. So what that means is that between 1 and 2, and we can kind of see it right here, between 1 and 2, they have to cross over each other because it changes from being smaller to bigger. So there has to be a solution there. So that means right here, between 1 and 2, there would be an answer to that graph. Okay, and then again, do you see how it changes between 3 and 4 where it goes from being bigger to smaller? So do you see how somewhere in here that the lines cross again? So that means there has to be another solution. So again, there's an answer between 3 and 4. Oh my gosh. Okay? And I would just kind of change a note here that we saw that f of x changed from bigger to smaller or smaller to bigger. I'm just going to put bigger / smaller, and you know it goes both directions. Which means the graphs intersect. So hopefully that will kind of let you know what's happening. So whenever they're changing from bigger to smaller or smaller to bigger, they're going to have to cross each other. Okay? And so then I'll probably go back and erase this so that I can make some new values here. And so you can see that you can either look at the graph or you can look at the numbers. I personally feel like the numbers are easier to look at because the graphs I can't always tell exactly what's going on, but it's completely up to you. Okay, so B now is asking you the same thing, but it's asking you that when f of x equals h of x. Okay, so we're trying to find when do f of x and h of x cross over each other. So do you guys want to look at it on your own for a minute? See if you can do it? So that means we're looking at the top line and the bottom line. So the first one for f of x and h of x, which one, if we're just looking at terms of f of x is smaller or bigger than h of x? Smaller. Okay, on the next one, f of x is smaller. Here it is smaller. Here it is smaller. And here it is smaller. Do they ever cross then? No. So that means on this one, the answer would be no solution. And I'm going to write f of x is always smaller than h of x, so no solution exists. Yes. Okay. If you can wait till the end of notes, it'll be better, but okay. All right. Is it clear on B why it's that way? Do we understand? Yeah? Okay. So I'm going to go back and erase these again so that we can do our next one. And I'm going to give you a minute here to try C on your own. And see if you can get it. I'll walk around and kind of check answers as you're going through it. Okay, so back here on C, it's asking for when g of x equals h of x. So we have to find where they would intersect, or which two values they would intersect in between. So if we go here, we're looking at our g of x and h of x. So on this first one, g of x, is it bigger or smaller than h of x? Bigger. Okay, and then here, it is what? Smaller. So right here we know, see how it changed from being bigger to smaller? The two graphs would have to intersect. And if we look at g of x, which is green, and h of x, which is purple, do you see how there's a point that they intersect there? And so somewhere between 0 and 1, there is a point of intersection. So on your answer right now, we could go through and we'd highlight from 0 to 1 because there is a point of intersection from 0 to 1. Okay, and we need to see if it's going to cross anywhere else, so we'll keep going through here. So then on the next one, is negative 2 bigger or smaller than 1? Smaller. Negative 6 and negative 2, smaller, and then bigger. So if we look here at our graph, in between 3 and 4, it looks like they intersect again. Do you see that here? How the purple and the green look like they intersect again? And we can see here, because it went from small to big, that they have to intersect. And so we would highlight in between 3 and 4. So there's an answer between 0 and 1 and also 3 and 4. Okay? So far so good? All right. So I'm going to erase all that again so that it's... Okay, D. On D it says, on the number line below, shade the intervals between the integers where the solutions to f of x equal negative 3 and g of x equals negative 3 must exist. Okay. So let's start with f of x. So they're wanting to know, where is there a point where f of x will end up being equal to negative 3? Okay. So, is negative 3 in between negative 2 and 0? No. Is negative 3 in between 0 and negative 1? No. Is negative 3 in between negative 1 and negative 4? Yes. So right now I'm going to go highlight between 2 and 3. Okay? And then is negative 3 in between 3 and 4? Or between negative 4 and negative 2? Yes. So it could also be between 3 and 4. Okay? And that was for f of x equals negative 3. So I'm just going to put f of x there. And then I'm going to highlight here below to see where they both, to see what happens with my g of x graph now. Okay? So now I have g of x. So if we look at g of x, is negative 3 between 4 and 1? No. Is negative 3 between 1 and negative 2? Is it in between negative 2 and negative 6? Yes, so I'm going to highlight there. Yeah, you might want to use a different color. So you can see the difference. And then staying on g of x, is negative 3 in between negative 6 and positive 1? Yes. So it won't always work out this way, but they both of them will have solutions at negative 3 between 2 and 4. Oops, you can't see what I wrote. All right, questions? Okay, the last one. It says on the number line below, shade the intervals between the integers where the solutions to h of x equals 0 must exist. So this is the same as the last D example, but we're looking at when will h of x equal 0. Okay? So you're going to be just looking at your h of x and looking at the numbers to see when it would hit 0. So I'll give you a little bit of time to try it on your own first. I just didn't want to highlight mess up your one. I hear you. Okay, so you just missed one. So 0 is 0. Yeah, so that's, and then the other one's right. Okay, so when we're trying to find if h of x equals 0, I like to go back and just look at my numbers. And between negative 1 and 3 is 0 in between negative 1 and 3. Yes, it is. So between 0 and 1, there is an answer of 0. Okay? Between 3 and 1, is there a 0? No. Between 1 and negative 2, is there a 0? Yes. And so those are between the numbers 2 and 3. So I highlight between 2 and 3, which you can see there. And then between negative 2 and negative 1, there's no 0. And so that's my answer, is these two separate intervals. All right, any questions?